So, the idea, as the psychologist explained it to me, is the idea of free lunch learning. And there is a saying that there is no such thing as a free lunch. But I shall give you some evidence, partly in favour of this and partly against. And what this means is that nothing in life is free. We have to work at everything. And even if somebody says, come and have lunch with me, I will buy lunch for you, probably he will expect you to do something in return. So that's the statement. There is no such thing as a free lunch, but in red here, in learning theory, there is a free lunch in a sense that I shall explain. So let us suppose that we learn some foreign language and we learn two different lots of words called A1 and A2. And A1 involves N1 associations, things. So for me, A1 could be some easy Japanese numbers. So I know that 1 is ichi, 2 is ni, 3 is san, and so on. And then I learn A2, some other words. I learn that a baboon is hihi. I learn that cat is nekko, and so on. And then I go back to Scotland for 5 years and I forget all my Japanese. And then I come back, so that's stage 2, forgetting. Stage 3, I relearn only some of the words. So I sit down with my little book and I see, yes, cat is nekko, baboon is hihi, and so on. And that helps me because suddenly all the words in A1 come back to me. I remember the number words. And that, in some sense, is a free lunch because the work I have done is only on A2, the animal words. What comes back to me without my working is A1. I would be very interested to know if you too have had this experience. So if you've had this in learning some foreign language, please wave your hand. No? Okay. Some people have it, some people haven't. Perhaps you have met it in some branch of mathematics. And now I have to tell you that I'm very sorry. This has not happened for me on this trip to Japan. I think the problem is I just don't know enough Japanese. Okay. So this thing, this is the anecdote, this is what people have seen. What other evidence is there? Well, there was an experiment in which Dr. Stone and his wife, who is also a psychologist, did this experiment. So they took a computer keyboard and they changed the wiring. No, they didn't change the wiring. They actually took the letters from here and put them up there. So they changed the order and then they got people to use this until they were used to it. So there were two different sets of letters, which we can call A1 and A2. People were taught about these two sets of letters. Then they went away. They had a chance to forget in step 2. They relearnt the set A2 and A1 came back. Not perfectly, but some of it came back. So there was, in that sense, a free lunch. So not only is there evidence from experiments, one can also look at this in terms of artificial neural networks. So an artificial neural network is a bit of mathematics which represents a simple version of what we think happens in the brain. So we have a vector space Rn, and in it we have something called a weight vector W, and the job of that is to change an input, which is a vector x, into an output, which is a number y. So x might be, in my case, 1, that's the input, and the output is Ichi. Or perhaps when I get it wrong, it might be something else. Now, the thing to notice is that this is very simple. This function, in goes a vector, out comes a linear transform of the vector using this linear map. So my notation for vectors, I think of every vector as being a column. So that is x. W is also a column, but W transposed is a row. So I have W transposed acting on the column vector x, and I get a 1 by 1 matrix, or a real number y. So now we, or computer scientists, teach an artificial neural network. We say whenever there is input x1, you should give output d1. Whenever there is input vector xc, you should give output dc. So this is a kind of machine that you put vectors into and you get numbers y out of. And if you train this machine, or if you set things up properly, you get a weight vector w, which lies in this set. It's the set of w's for which x acting on w gives you the vector d. Right, so what are these things? D is a vector. I've written it here as the transposed of a row vector. D contains the outputs you would like, scalar d1 up to dc. And what about big X? Big X is a C by N matrix whose transpose is just the columns of the inputs x1 up to xc. And then, just as the human brain forgets, or mind forgets, artificial neural networks forget. And there are two ways of forgetting, called synaptic drift and synaptic decay. These are just words for psychologists. So let's look at the blue, and I will tell you what really happens. So you can think of it as there being W represents some signal, and in drift the signal moves somehow, it moves randomly, the way the green dot is on the screen, and in synaptic decay the signal decays, it gets weaker. So you can imagine that the things that are happening in the neurons are that there are electrical pulses, and it's a strong signal if the electrical pulses go very quickly, or rather you get a lot of pulses per second, and you can imagine that with very old people like me, the pulses get slower. Right.